Hi, my name is Kalyan Akneni. My topic for Big Data Analytics course at Harvard University Extension School is ClickStream Analytics. Um, let's look at what ClickStream data is. ClickStream data is a log trail that is created by a user when he clicks on a website, on a web page. We can get a visual trail of user activity using the ClickStream data. And also business and marketing teams can use this data to improve their sales. Let's do a little background on the sales activity in 2017 alone. The online sales of physical goods amounted to 446 billion in US. By 2022, it is estimated to surpass 700 billion. According to e-consultancy survey, a customer on an average spends around 4 to 5 minutes browsing on a website um, before purchasing, but on an average this conversion ratio or is only for 1.4%. One of the many analytics we can use and invest to drive revenue is clickstream analytics. So our problem statement is we'll see how we can use the clickstream data to see if we can predict if a customer is going to buy the product or if he is going to leave without buying the product when he clicks on a website. So the software and hardware we used in this for to do this project is Apache Spark 2.3, Python 2.7, Spark Data Frame, Spark SQL, Azure Machine Learning Studio, CentOS 7 virtual machine. Coming to the data sets, I got this data set from a YouChoose website. It's a sort of online challenge given to some participants a few years back. They were asked to predict they were given a data set and asked to predict if a customer will buy the product or will not buy a product. So I have taken the data set. Here is the website. You can download the data set from this website. There are two data sets. One is a click data set, another is a buy data set. Click data set contains all the click session level information, like what's the session ID, what's the product ID, what's the timestamp, date and timestamp, what's the category, etc. This file is around 30 million. This file has 30 million records and it's 1.5 gig in size. Other is a buy dataset. Buy dataset is nothing but this a subset of it. It has the session IDs with a um, subset of click datasets. So it has only the session ID where customer brought a product. So it has the session ID, the product ID, and the timestamp associated with it, and the quantity of the products he bought. So let's here are the overview of steps I have done. I have read the source from the files into a data frame, applied transformations, summarized the data into a single data frame, and fed the data into Azure Machine Learning Studio software, and then I trained the model, and then did a predictive model after that. So let's see how I have done this. Let's go to the actual code itself. So let me show you the actual data frame after reading from the um, files. So here is the click data frame. It has the session ID, the date and time of when the click happened, the item, which is the product ID, and then the category, which is like if it is a sport category or if it's a grocery, etc. And then there is a buy data frame. Buy data frame, the all the session IDs that you see here, buy session ID. The buy session ID is a subset of click session IDs. So anything that is in the by data frame session ID is also in the click session ID, and then it has the time frame of or date time when the customer bought the product, and then the item or product what the customer bought, what's the price, and the quantity that he brought. um, so let's see. So I've just aggregated this data to get all the session IDs and then how many clicks he had made. So I aggregated the data and created another data frame. And similarly, I did the same with the by data frame, um, and then did several transformations. Like I used min max of the time frame for each session the customer spent, and created a final data frame which shows something like this. um, so using the click and buy data frames, I did several transformations which I have included in my code, and come up with a final data frame which shows something like this. So I have the session ID, I have a count, I have a bot indicator, I have a duration. So which means that for this session ID, this many clicks happened, and for that many clicks, the customer did not buy a product, and the duration he spent is he did not spend. It's just one click. So he didn't do any subsequent clicks on the website, so he didn't spend much time there. So because we are just showing the five, um, we are not seeing any duration or broad indicators, but if we but the data is there. So after this, I have loaded this data frame into a CSV file and fed to a local directory. So from the local directory, I have taken that CSV file into Azure. In Azure, we just create a user ID, set up a free account, and then we do something like this. First, we have to read the data frame. If we have to read there are several modules in here, so we have to go one by one, which I've explained in detail in my Word document, how to pull in each module in this workflow. So the first one is the CSV file that we exported from the data frame from Spark. That's the input, that's the data source, data set, and from the data set we are getting the data into a next module where we select the columns that we need for this module, and then I've used regression model to do it. I split the data into testing and training model, which is so 75% for training and 25% for testing. So I give the input to the train model and then the next to the score model. So both of the training and the data goes to the score model, and then from the score to evaluate. So once I have done it, I save it, and then once I run it, um, it executes all the it creates a model and then saves it. Now I let's see the results, how this is showing. So for the train model, the results I have got are something like this. So these are the results I got. I got a ROC curve, something like this, accuracy of 94%, ROC of 72, um, and then these are the scored probabilities, and these are the scored labels for 0. These are the predicted values that you see here, and then um, let's see. Okay, so once this model is ready, you have to set up your web service. So you once to set up your web service, you click the setup web service and just say predictive web service. Once you click it, it creates another module combining all these modules into a single module, which shows a web service input and a web service output. If needed, you can delete this one here and give your own input and run it. So you save it and you run the same predictive model, it will create a predictive model. So the clickstream project that you see here is a result of the training model you have done. So this is the training model, it's taking it as an input to score the model. So once this is done, you can deploy this code. Once you deploy this code, you you will see a screen something like this, where you can test the actual values manually. So here you can get, once you click the test, it shows a screen to input values, or you can export the Excel into an Excel, but here on the Mac it won't work because it needs another API. On in Windows, this one will work definitely. And then this also will create a Python code. Once you click the request response here, it will create a Python code. So it will create a C plus C sharp code, a Python, and an R code. You can copy this Python code, and then in the place of the API key, you have to go back and copy this API key and give it to the developer, whoever is developing, so that it knows which module to pick, and then they can execute it. So that's how I have done it. um, Let me show you the output of what I've done. So I've copied the Python code into a test py, and I am executing it here. So here are some lessons learned. First, I tried to implement the machine learning module in Spark ML um, framework, but I was getting some issues. Probably it's because of the dataset size or the number of variables. It's been continuously failing. I tried to research it, but the time is running out. So I tried looking into some Azure ML Studio uh, library or videos, and then I was able to uh, test it out with my sample data, and it was fairly very easy. And there were a lot of algorithms to use, and it's all up to us to determine which one to use. And if you know which one to use, it would be fairly simple, and it would be very much time saving using Azure ML, um, because it's pretty much faster. Like it executes the data also faster. Like um, my file is around 350 MB that I input to the model, and it fairly took like less than 5 to 10 minutes to process the whole data. um, thank you.